escape. So you can see it slowly swinging in direction according, it's varying the azimuth, basically. From minus 50 to plus 50. Not that many steps. Okay, so here we've got a series of spheres, and we are varying the components of specular strength and diffusory strength from 0 to 2. So the higher the specular strength, the brighter the specular component, and the higher the diffuse strength, the brighter the diffuse component is. So down here, there's nothing but the ambient term, and then the diffuse is stronger as you go up that direction, and then going across here, the specular strength is the same, is increasing as you go across, but the ambient, the diffuse is the same. Okay, so these pictures are important because they're on your homework assignment. All right, is to generate images that look at the variation of specular strength and diffuse strength. So here we're combining the ambient strength on one axis and the ambient light color. That's a little confusing. Okay, let's look at it this way. The sphere itself is red, so it's going to reflect red, okay? Is there any red here? No red. So stay away from where the diffuse light is coming in and concentrate, far away from it. Is there any difference in color from the three? The answer is, I hope, no. If there's a little bit of red, then that's going to appear there. Right? And there's even more red, and that's going to produce a stronger red effect there. Okay. So here's specular exponent quantity. Remember, the bigger it is, the sharper the specular highlight. And they're saying typical values range from 1 to 500. Normal objects have ranges 5 to 20, looking realistically. So if you look at this example, does one look, does a specular exponent of 1 look right? And I would say no, I don't, that's not the way shiny balls look, in my experience at least. I don't even like 5, I think that's too big. But 15, I'm beginning to accept that as far as a specular component. Okay, so here we're going to leave the specular index the same, and we're going to vary the specular reflectance. Okay, so if we have 0 specular reflectance, there is no highlight. If we have 0.5, there's a highlight, but not all that bright. And if you have 1, you have a very strong reflectance coming out of it. Probably too strong. I like 0.5 better. Okay, there's a flag you can set that determines what you do with the backside of faces. Suppose that we had a sphere, all right? Do we care what happens at the backside? No, because there's no way to look at the backside. But in the case of this particular shape, we do care because we can see part of the front and we can see part of the back. So the default is just to do front face lighting, and there's less calculations involved there. But that wouldn't be really relevant on this one because we can see both, at least parts of both the front and the back. So that's what the back face lighting. Ordinarily, the facet is going to be an outward pointing facet. For the backside, you've got to turn that vector around so that it's an inward pointing direction. That's what they're talking about. Direction of surface normals got to get reversed for the inside facets. So here's another example. We've got a sphere, and we have a cube that we're generating. First one is the sphere, and then we're creating a patch below. Okay, and we're specifying the material as being shiny. So that's going to pick some characteristic reflectance values that MATLAB feels is appropriate for shiny surfaces. Doesn't really apply much to the cube because the viewer is not positioned in such a way as to see the specular reflection. There aren't enough directions coming off of the cube, whereas for the sphere, something along the body diagonal looks like it's where we're going to be able to observe the specular reflection. But that isn't. If we rotated the cube around, we might be able to see that. Let's try that. See if this works. No. Wait a minute. Okay, I've managed to, well, that doesn't look quite as white here. Looks different on mine. Nah, still, well, if there is a specular highlight, it's going to be over the entire surface because it's flat there. All right, let's run it again. So take a look at the sphere and watch the specular highlight position change. I'm not affecting the relative position of the light, but I am affecting the relative position of the viewer. So that changes the highlight position. Okay, so here's our material. So shiny, there's the ambient, the diffuse, the shininess, the coefficient is 2, and the specular color is 1. And then for the dull, bigger diffuse, no shiny coefficient. And for the metal, it's even a bigger specular component and even less of a diffuse component. Go figure. I don't know why MATLAB chose those values. Typing the command was no help whatsoever. We tried that. How come that doesn't show up on my screen? Oh, enable comment. All right, we're back. I don't know. I must have a like a movie or something enabled in there someplace. All right, so some of this is review. There's a function called cam light that determines a light source relative to the camera. Right? One strong one is or popular one is the camera headlight. And that says that right where the camera is, there's a light shining at it. Okay? We'll see that in a second. We've looked at light angle, which does determines the directionality based on azimuth elevation. We've looked at the light, which creates either a directional or a point light. The lighting method we've looked at, material we've looked at. So here's the cam light. Basically, we can pick, I mentioned headlight. There's also right. So the light is going to be to the right of the camera and up a little bit. I don't know how far. Maybe determined by azimuth elevation, and then cam light left. So as the camera moves around, the light moves around. You can get this from the help menu. Here's an example. I wonder if that's going to run. We won't worry about it yet. Okay, we talked about this, shading algorithms. And we saw this slide. Here's the light objects. We saw that. We saw that. Light style. We saw this example. Looks like there's a repeat there from what we had before. Ta-da, so we're finished. Okay, so here is the last homework, okay, which consists of just 2 problems because we're running out of semester and I think there's a little bit of a homework backlog out there, so this should help alleviate that. But I did want you to, play around with the lighting function, so this is an excuse to do that. So we want to demonstrate an example that looks not exactly, but looks something like that. And this is an example that goes between specular strength and diffuse strength. And it looks like the ambient must be pretty well off, right? Because that looks pretty black there. And then we want something where we vary the specular coefficient. This is suggesting 1, 5, and 15. You have my permission to play around if you want to use a little bit. You want to show kind of a range of values, but they don't have to be exactly this number. If you want to choose a little bit different numbers, that's fine. Here's the specular reflectance. And again, that's varying between 0 and 1. So that's problem 1. It's just, generate some examples of lighting in MATLAB showing variations. And then the second problem is I think we're going back to assignment 7, where you were creating a model of the checkerboard with your product on it, right? So take that model and light it, right? So pick some values. I would, particularly in the checkerboard, maybe find something where you can see a specular reflection off of there. So you'll have to pick the direction of the light, pretty carefully in order to spot that or to demonstrate the specular reflection. But just kind of play around and see if you can do something interesting with the lighting on that scene. And that's the second problem. So 2 problems. Should not be too difficult. Okay. And that will be due a week from Wednesday. I think I made it on Wednesday. And hopefully we can, if you get it in soon enough, we can actually go over it in class and comment and compare the results there. Okay. On Wednesday is standard symposium, and traditionally, we're supposed to cancel classes for standard symposium. So consider Wednesday's classes canceled with the idea that you're going to spend a lot of time over in the standard symposium seeing what other graduate students are doing on their projects, all right? So I won't ask you to write a report on it to prove that you were there, but that's the intent, is that you have the ability to go over there and do that. So on Monday and